Calling and bulolo with whatever we do. With whatever we do. Hale dem mun school. Nyep hamne ne kudlukula. Nyepangi ragala gena. Nyep hamne ne kudlukula. Ibuloke no moto ni beti sola. Ibuloke dato ni betoto.
Bege Congo.
Lamin.
Na.
Lamin ke jibe norin te nyame Lamin.
Kabona wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Nole Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara mu.
Ndele bare muso.
Lunda mana.
Kamo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramu do kontan.
Ngoto minaka ngala min de fon filitala Lamin jibe nori nyala.
Lamin ile siran sama ne benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karamu ngoto. Anu sayeng ministry ko di ngole si suwo ko amanke ko do holiday. Si bitun.
Bagona de.
Ala ko kede namo balo.
Ala ne na ko na karta bulo be dam ala nije.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu ne keda.
Ifike Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyande sila la be la moy kala karango.
Jamani karamol be soron ne ko fasita wulo ko nako.
Karambol ma soron ni ko karambol soron da amanke comme holiday lem. Ngoto. Dini wo nyanta sila la ala karango la moy yamen kaben fue. Man kontan andamande.
Allah nyin kombo kurang ada ndalo kombo ndo la jankara mol soron da doro kabe kurang ma do lo kombo e don dol fana na kara mol soron je kara mol soron Lamin ada lo nyino la aman tara fe na sokon ala mu nekela
Lamin ite fo de malon ko lesinol be ke kar radio to
Nga fine.
e ko nyani mo Lamin ya mu na fonye
kabe mina kan tambita nteri maning Fatu tambite la sukala ala dinni wol bebe siri be la moy ka
faru danso am fana tambita jele ni subala la ngaje dinni wol be jet talanta nen kili warol e be seri jelet
sa Lamin fadante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin
aman dara fenela
ite dine ko ni man si yakari lesinol la moy radio to e balon na
mu ne ka ke afende ma nyara ni alon
telentel jikot
afende ma mu ne be ke
ite balon tel be jikritel ni man kara ku kele yaje nata kara namba samala ya itarije
par ñarande kombo courant ho findira kombo ide na rajede ni sonka bay ko Lamin ma ñata la wulo ko karam
ngoto wole nati bawo ngalle ni Lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulan koto batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
il est subjecteur baby jele i baby jele
wala nan ka coco moy fa dan so wolya ngombe tambi kana ngadi ni wolde be ikadum bungo de ko kala
mo asototal de
Lamin mala be karade
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ha ko nde ko folle sinila mba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fana bulata ko ko me yen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wora ka munda kara mo man soro Lamin nyanta kara si so na regular
la sila le ayala le sino
dal ko korno ko smalo
kilar ya
mo be ngala ko momo say mi do ni ko no kera
mengi bruce
ndelo ko la da ba rosa no radio ba no bari woro radio ni abe jele ba ngam do man dembe buljan dala nyara nyar wo ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
mengi mun na de
teku teku
bari ko do famo ke
imagine nañu ñambol
ha
sisol le keje kisigi man sisol no le kafun ka ñoma bari ñambu kino ni mañana ka finde ni nambe ko so la ni nambe ko so la
ngalle limbeta de be ñambo do dilanna
ñara nim ko ridin fennat ñara nata
ha bari famo ke da
ngata bungono tammi bungono ñara me ngando ko fele ko ke e bar nganda ni pelo la ndija
iyo awa betar la
bungono bismillah bisu diara
pendulala yefungo tanka sina dolu tanka koro korota korota.
Viewers and listeners, welcome to the continuation of the topic on mixed operations on fractions. The last time we met, I did give you some try questions which I want us to try together and then see if the solutions we have will be the same as the ones that we're going to solve together. Now, the first try question, we are asked to simplify a 2/3. That is a 2/3 divided by a 6/8 minus a 2/5 times a 1/4. This is the question that we are given. So we are asked to simplify this. If you take a look at the question given, you will realize that we've got 3 different operations. What are these operations? You have a division sign, and you have a minus sign, and then you have a multiplication sign. In short, the question is on mixed operations. And how are we to solve questions on mixed operations? We need to remind ourselves of what we've discussed in our last lesson, and that is the board mass. What does this exactly mean? That is, the B here represents the bracket. And if you looked at the operation given, there is no bracket among the operations that are given. The O here represents an off. And if you equally take a look at it, there isn't also an off given. The D here represents a division. And among the operations given, we've got a division sign. What is dividing what here? And that is to say, the 2/3 should be divided by a 6/8. Put that in a bracket to simply mean that you're coming to start with this operation. Then minus a 2/5 times a 1/4. Dividing a 6/8, meaning this division sign should change to a multiplication sign. And then the number immediately after that be inverse. And that is, the 6/8 becomes an 8/6. Then you also maintain the bracket. Then minus a 2/5 times a 1/4. Then what are we to do here? We have to look among our numbers in the fractions which could divide each other. Now, we all know that the 2 here is a numerator, and then the 6 is a denominator. So in short, what is common to both? Meaning a 2 is common. Meaning the number of 2's in itself is 1, and the number of 2's in 6 is 3 times. So what we're going to have in the bracket as our new fraction will be a 1 times 8, which is our numerator 8, divided by a 3 times 3, which is going to give us a 9. So the division of the two numbers, that is 2 over 3 divided by a 6 over 8, will leave us with an 8 over 9. This 8 over 9 has to subtract a 2 over 5, and then the result we multiply by a half, by a quarter. Now, if you looked at these new operations in the question given, you will agree with me that we've got two operations. One a minus sign, and then the other a multiplication sign. Still, the operations are mixed. So again, we need to reflect back on the board mass. We've realized that there is no B, which is a bracket. There is no of, which is the O there. There is no D, which is the division. But there is an M, which is multiplication. So we've got a minus and a multiplication sign. Of course, in the board maths, the multiplication comes before the what? The minus sign. So what we equally have to do here is to also multiply, take on the multiplication. Now, in the equation, in the operation, we have an 8 over a 9 minus. Is there any number that could take on each other? The 5 is a denominator, and we have a 2 and a 1 as our numerators. 5 can't divide any one of those two. Muso 2. But the 2 can take on the 4, meaning the number of 2's in itself is 1, and the number of 2's in 4 is also twice. So what we'll also have in the bracket, that is in the multiplication of a 2 over 5 times a 1 over 4, will leave us with a 1 over a 10. How do we arrive at that? A 1 times 1, that is the numerators, will give us 1, which will serve as the numerator. And the 5 times 2, that is the multiplication of the denominators, will give us a 10. Now, what do we have as our new what? Operation, or as our new question? We'll have an 8 over 9 minus 1 over 10. Both are fractions. And if you looked at the two fractions, the denominators are not equal. One of the denominators in the first bracket is a 9. And then the denominators in the second fraction is a 10. What are we to do? What we'll do here is to make sure that the denominators of the two fractions are equal. How can we make them equal? That is, we must come up with equivalent fractions of each of the fractions that are given. That is, equivalent fractions of the two fractions that are given in the question. And how do we go about doing that? That is to say, we'll have an 8 here, which has to be multiplied by 10, because that is the denominator of the second fraction, all over the 9, that should also be multiplied by 10. Now, if you've done that to the first fraction, a similar thing should also be done to the second fraction, which is 1 over 10. With 1 over 10, the denominator of the first fraction, which in this case is a 9, has to multiply the 1, and then also go on to multiply the denominator 10. Now let's see what equivalent fractions we're going to have. And 8 times 10 is 80. That is our numerator. Then go on to multiply the denominator, 9 times 10, which is a 90. Now, an 80 over 90, when simplified, will be the same as an 8 over 9. So 8 over 9 and the 80 over 90 are equivalent fractions. Then a minus. Let's see what the product of the second fraction is also going to give us. A 1 times 9 is a 9. And a 10 times 9 is also a 90. A 9 over 90, when it is also simplified, will also lead us to 1 over a 10. So what we did was, we've come up with the equivalent fractions of the newly formed fractions that we have. And again, went on to have what? A common denominator. Like if you looked at the previous fractions that we have, that is 8 over 9 and a minus 1 over 10, the denominators were all equal. But if you looked at the second fractions that we've just created, the denominators are equal. And what does this remind us of? That when the fractions of a common, when you have fractions with the same denominators, what we need to do is if we are adding or subtracting, and in this case we are subtracting, we take the difference. That is 80 has to minus the 9, the numerators has to take on each other, and then a common denominator be taken. That is 80 minus 9, which are the numerators, which will leave us with a 71, all over a common denominator 90. Now let's take a close look at this. 71 over 90 is a fraction. But can this be further simplified? Is there any number that could divide the 71 and the 90 without leaving any remainder? The answer is no. There is no such number. Now, can the 90 further, if you look at the denominator 90, it is more than the numerator. Meaning, our result could either be in this form or in decimal fractions. Now, let's take a look at the second sample. The second try question. In the second try question, we are also given a 3 whole number 3 over 4 minus. Then inside the bracket, we have a 3 over 4 and a plus 1 over a 2. Then of 4, which is outside the bracket. This was the question that we are given. How are we going to also simplify this? Now, what we need to do here is to first and foremost change all the mixed numbers to improper fractions, if there is any. And in the question given, there is a mixed number. What is the mixed number? It is 3 whole number 3 over 4. This 3 whole number 3 over 4 has to be changed to an improper fraction. Remember in our last lesson what I did, or what we've done together. That to change a mixed number to an improper fraction, the denominator of the fraction has to multiply the whole number. And in this case, the denominator is 4, and the whole number is a 3. So a 4 will multiply a 3. The 3, that is the whole number here. 4 times 3 is 12. Then the 3 that is in the numerator, that serves as a numerator, should be added to the 12. Meaning what we'll have here is a 15. Meaning 4 times 3 plus a 3 is 15. The result there should be divided by the denominator 4. Then minus the value in the bracket, which is 3 over 4, plus then of 4. Is this the answer to the solution? Nothing is done yet. What we did was only it's of the mixed number to an improper fraction. Now, what is it that we're going to do here? Let's check on to see the number of operations that we have. First, we have a minus sign. And we also have a plus sign that has been enclosed with a bracket, the addition of two numbers that have been enclosed by a bracket, and then an off. Because it is mixed, the rule is we remind ourselves of the board mass. And what is in the bracket? That is a 3/4 plus a 1/2. So that should be solved for first, because there is a bracket. How are we going to do it? Again, we could have a 15/4 minus the 3, because they are adding, should be multiplied by 2, and the 4 be multiplied by 2. Why? Because we take in the denominator of the fraction, or the second fraction in the bracket, to multiply both the numerator and the denominator. Then plus a 1/2. In this case, this 1/2, the same treatment given to the fraction 3/4 should be given to it. A similar treatment. I beg your pardon. Multiply the denominator of the fraction, which is 4, with the 1, and then also go on to multiply it with a 2, with a 4. The 2 here with a 4. And then off 4 to complete the question given in the operation. Now, what are we going to have as our new equations? We will have a 15/4 minus the product of a 3 times 2 as our numerator, which is 6, and then the product of 4 and 2, which is going to give us an 8. Put that in a bracket. Then plus, which is a 4, and then a 2 times 4, which is also an 8, and then complete the question, that is of 4. Now, inside the bracket, of course, if you looked at what we had initially, the denominators weren't common. That is the 3/4 plus 1/2. You will realize that the denominators were 4 and the 2. They weren't equal. But what we have in our newly created bracket, you will observe that the denominators are the same. What are we to do here? To apply the technique. And the technique is, we will sum up the numerators, that is 6 plus 4, which is a 10, and then we take a common denominator, which is an 8, then off a 4. Now, initially we had we have more than 2 operations, but now we've got 2 operations. That is a minus sign and an off. In the rule of board maths, which one comes first? The off should be solved before the what? The subtraction. So since there is an off here, that is 10/8 of 4, meaning that is what we should solve for first. And in this case, we'll have a 15/4 minus, inside the bracket, we'll have a 10/8. The off here has to be changed to a multiplication. But that does not affect the number immediately after it, meaning it should not be inverse, but should remain the same way. Of course, you will have a 4/1. 4/1 simply means a 4. What I wanted is uniformity, so that I will have fractions in both. Now, what number can cancel out here? That is 4 could reduce the 8 twice, meaning when 4 divides itself, it is 1, and the number of 4s in 8 is 2. Is there another number that could also what? Reduce, or are there any numbers that could reduce each other? Of course, the 2. The number of 2's in itself is 1, and the number of 2's in 10 is 5. Are there any other? No. What is it that we're going to have as our new question? We'll have a 15 over a 4 minus a 5 times 1, which is 5, all over a 1 times 1, which is a 1. What is it that we're going to have here? Again, the denominators are different. And since the denominators are different, we need to what we're going to have here is a 15 over 4. Of course, the denominator of the second fraction, which is 1, has to multiply the 15 and then also go on to multiply the 4 in the denominator. What we're doing here is we're trying to make sure that our denominators are the same. Then minus a 5 over a 1, meaning the denominator 4 in the first fraction should multiply the numerator and then also go on to multiply the denominator. Now let's see what we're going to have as our result. A 15 times 1 is a 15. And a 4 times 1 is a 4. Meaning the equivalent fraction, meaning this 15 over 4, is the same as the fraction that we had initially. That is, and then minus a 5 times 4 is a 20. Likewise, 1 times 4 is a 4. Meaning 20 over 4 is equivalent to a 5 over 1 that we had in our previous fraction. Now, if you observe the newly formed fractions, you will agree with me that the denominators are the same. What are we to do here? We need to look for the difference of the two numerators. That is 15 minus a 20 over the common fraction 4. And a 15 minus 20, that is to say you have $15 and you are asked to pay back $20. Obviously you can't, you only have to run in a deficit. So a 15 minus 20 will not give us a 5, but instead a minus 5 divided by a 4. So what we're going to have here is a minus 5 over a 4. Is this simplified? It is not. Now, since it is not well simplified, is there any number that could divide the 5 and the 4 without any remainder? There is no such number. Now, let's look at the two numbers. Where do we have the least number? That is in the denominator. The 4 is less than a 5. So what we're going to do here is to use the 4 itself. Meaning, this negative sign does not have what to cancel it, but the number of 4's in 5 is 1. Remember what? The 1 over 4. Meaning our result here will be a negative 1 over 4. Next slide, or to the next question. We are asked to simplify a 1 whole number 4 over 5 divided by a 9 minus 1 over 12 of 2 plus 1 over 3. Now, what have you observed with this question? We've got mixed numbers among the numbers given. What we're going to do here is to make sure that the mixed numbers are changed to improper fractions. And as such, we're going to have the 1 whole number 4 over 5 written as a 9 over 5. How do we arrive at that? That is, the denominator of 5 multiplies the whole number 1, and then the numerator added to it. The result attained should be divided by 5. That is, a 5 times 1 is a 5, plus 4, which is a numerator, will give us a 9. And then because the 5 is the denominator, we have to divide everything by that, by the 5. Meaning 1 whole number 4 over 5 is 9 over 5. Divided by a 9 minus a 1 over 12 of a 2 plus a 1 over 3. Now, if you looked at this, the question is yet to be properly what? Simplified. If you looked at the question, how many operations are involved? We spoke about the division sign in there. There is a minus sign in the operation. There is a positive sign in the operation, that is a plus sign, and then we also have an off, meaning we've got more than one operation. Now, since we have got more than one operation, to solve this question, we need to what? To remind ourselves of the board mass. What does that imply? That to solve these questions, the bracket should be treated first. And is there any bracket in the question? No, there is no bracket. What else is in the bracket, in the question? That is an O. What does that imply? An off. And off here is in the question, meaning we have to solve that first. Since there is no bracket, an off should be solved. Next. So we'll have our 9 over 5 divided by a 9 minus what is now in our new bracket, that is 1 over 12. The off here is changed to multiplication, or multiplied by a 2 plus a 1 over 3. Now, what is in the bracket that can cancel out? That is a 2 and a 12. The number of 2's in itself is 1, and the number of 2's in 12 is a 6. So to take on our problem, we'll have a 9 over 5 divided by a 9 minus the result of what we have in the bracket, that is a 1 times 1, which is a 1, all over the denominator 6 is 1 over 6, plus a 1 over 3. How many operations are we left with? We've got 3 operations. The division sign, the minus sign, and the plus sign. Which one comes next after the off? Is the division in the word what? Board mass. Is there any division? Of course there is. What is dividing what? 9 over 5 is dividing a 9. So we also have to enclose that in a bracket. Meaning we have to have that solved next. That is, a 9 over 5 times a 1 over 9, because what we are told here is each time you change the division sign to multiplication sign, the number next to it has to be inverse, and the number next to the division sign is a 9. So the inverse of 9 is 1 over 9. And this is why we have a 9 over 5 multiplying the 1 over 9. Minus a 1 over 6 plus a 1 over 3. Is there anything that could be further simplified in the bracket? Yes, there is. That is, this 9 could simplify this other 9, meaning the number of 9's in 9 is 1, and the number of 9's in the 9 that serves as the denominator here is also 1. So what will we have as our new fraction in the bracket? That is a 1 times 1, that is the numerators that I am multiplying, A 1 times 1 is obviously a 1. And then see if you could also multiply the denominators. That is a 5 times a 1, which is 5. Meaning a 9 over 5 divided by a 9 will leave us with a 1 over 5 minus a 1 over 6 plus a 1 over 3. Here we have two operations. And what are these two operations? That is addition and subtraction. If you can recall the lessons you had before this one, you will agree with me that you were adding and also subtracting fractions with a different denominators or with different denominators. How were you doing it? That is, the first fraction, which is 1 over 5, the denominators of the fractions involved should multiply the numerator and then the denominator. And what are the fractions that were involved? Those denominators is the 6 and the 3. So the 1 has to be multiplied by 6, and then also be multiplied by 3. And then the denominator of 5 should also be multiplied by 6 and also a 3. Then minus 1 over 6, which is the second fraction, should also what? Be multiplied by the denominator 5 of the first bracket and the denominator 3 of the second bracket. Since we've multiplied the 1 by 5 and 3, we should also multiply the denominator 6 by 5 and 3. And then the final fraction, which is 1 over 3, the same approach. Meaning the denominator 5 of the first fraction should multiply the 1, and the denominator 6 should also go on to multiply the same one. And then do the same thing in the denominator. That is, the 3 has to multiply by 5 and also be multiplied by 6. Let's see what we're going to have as our new product. That is, a 1 times 6 is a 6. A 6 times 3 is an 18. All over. What is the product that we have in the first fraction? In the denominators. We have a 5 times 6 is 30. A 30 times 3 is 90. So an 18 over 90 is replacing the first fraction 1 over 5. How? They are more or less the same, because the simplification of 18 over 90 could lead us to 1 over 5 that we have in the first fraction. Then minus a 1 times 5 is 5 times a 3 that is in the second fraction. We'll have a 15 all over. A 6 times 5 is 30 times a 3 is 90. Meaning the second fraction, which is a 1 over 6, is also equivalent to a 15 over 90. That is to say, when you simplify the 15 over 90, you'll get back to 1 over 6. Plus the final fraction, which is 1 over 3. What is going to be the equivalent to that? That is a 1 times 5 times a 6. That is 1 times 5 is a 5. Times a 6 is a 30. All over. The 3 times the 5 is 15. When you multiply it with a 6, is also 90. Now, in the first fraction that we had before, the newly created fractions, we had a 1 over 5 minus 1 over 6 plus 1 over 3. If you take a look at these fractions very carefully, you will agree that the denominators weren't equal. But if you look at the second fractions that we've just newly created, the denominators are equal. That is, when the 18 over 19 was simplified, if it is simplified, we'll have 1 over 5. And then the 15 over 90, when simplified, we'll have the second fraction is 1 over 6. And the 30 over 90, when simplified, will also give us 1 over 3. So nothing is changed. What we did was like to have an equivalent fraction to it, and then also have what? the denominators equal. What is it that we're going to do next? Since the denominators are the same, we're going to subtract where should be subtracted and add where should be added. Meaning, an 18 minus 15, which is a denominator, plus a 30, which is also another denominator, other numerator of the what? The first fraction, of the fractions, all over the common denominator 90. 18 minus 15 is a 3. A 3 plus 30 is 33. All over what? 90. Now, we have a 33 over 90. Can this be further simplified? Yes, it can. And how are we going to simplify it? Meaning we'll look for a number that will divide the 33 and also the 90 without leaving any remainder. And what is that number? Could be a 3. How many 3s are in this 3? Is 1. That is the first 3. Is 1. And how many 3s are in the second 3? Is also 1. Meaning the number of 3s in 33 is 7. Now, let's use the same 3 to see if it will also divide the 90 without leaving any remainder. The number of 3s in 9 is 3 times. But how many groups of 3 are in 0? Is 0. Meaning the number of 3s in 90 is 30. So to simplify a 33 over 90 will leave us with an 11 over 30. Can this be further simplified? Is there any number that could divide the 11 and the 30 without any remainder? There isn't. Now, if you also looked at the two numbers, where do we have the least number? That is in the numerator. That is 11. Meaning, this could not be further simplified. Our result could either be 11 over 30 or you leave it in decimal fractions. I thank you so very much for listening to the lectures, and I pray that you stay safe in your homes, stay away from the crowd, and make sure that you listen to the subsequent lessons that will follow this one that I had. Thank you very much.
Coronavirus. The World Health Organization has declared the coronavirus outbreak a pandemic. Here are some myths and facts about the coronavirus COVID-19.
Wow, Manduma Diga. Getting the coronavirus is a death sentence.
No, Lord Digger. According to a study by the Chinese